So my
Yeah.
topic is design of adhesive test apparatus and evaluation of adhesive strength of various biopolymer materials. So myself, our guide Dr. Santosh Jadhav sir, Amol Patil sir, and Gaikwad sir. Then this is my contents. Abstract in that purpose is the purpose of the study is to design and develop an adhesive test apparatus to evaluate the adhesive or peel strength of identify biopolymers. So you have to identify biopolymers and then find both numerical and experimental values. Then in that abstract design and methodology is biopolymers are widely used in medical field. We know because degradation products are immune to the human body. So these biopolymers are identified based on their Young's modulus. Because we want biopolymers whose Young's modulus value is very close to our human bone. So that we can use in the biomedical application, example, orthopedic applications. So it can fit to the human body organs. So that is the main methodology for this. Findings, analytical analysis is done by using ANSYS. And for experimental, a 90-degree peel test apparatus is in the stage of design and prototyping according to UTM dimensions, on which experimental studies are to be done. So the results are useful in the actual application of these biopolymers for orthopedic and other biomedical use. What is the practical implications? Selecting the biopolymers based on their Young's modulus, which should be very close to that of human bone, is challenging task. Keywords are there, and my paper type is either in design, material, or modeling. So this is introduction regarding the biopolymers. So these biopolymers are immunogenic to the human body. It is not like the cement. We know in dental treatment, cements are used, plates are used, but they, after some times, they get failed. There's a failure takes place. So because they are not immune to the human body also. So therefore, biopolymers they are derived from the living organisms. So they are very immune to the human body. So the main aim of this is to evaluate the peel strength. Now we have to find out the peel strength, adhesive strength of these biopolymers by using the peel test. So which is important parameters while implementing the devices in the system or in the body. So this is the test, typical 90-degree peel test. You have to peel the flexible adherent 90-degree from the fixed adherent and find out the force per unit width. That is called the peel strength. So by using 90-degree peel test, we can find out the peel strength. These are the different biopolymers for orthopedic use. You can see that their weight and their age. So it is used as a screw also in orthopedic application. Like it is not like a steel screws or others. So these are the very immune to the human body. So these are the literature, review of literature. So R. Rebello, his contribution is advantages of biopolymers. J. Pelfrey, cohesive zone modeling. W.T. Chen is he gives the idea about the 90-degree peel test. M.D. Thouls, thickness, peel strength and thickness relations. A.D. Kadam, natural frequency of single lap joint. And Mazem, it gives the quantitative test analysis for the thin films. This is the problem definition. We have to for 115 mm length, we have to find out the peel strength. Thickness, total length is 115, width is 40, flexible adherent is 0.13 mm, adhesive is 0.76 mm, and rigid, that is stainless steel, is 2 mm, like that. So what is the objectives? First is the survey of biopolymers whose Young's modulus is very close to that of human bone. Then do numerical analysis and do experimental analysis. And from that, you have to evaluate the results. This is a research RM, literature survey and gap findings, theoretical framework for feeling, material selection, analytical modeling, numerical analysis, comparison of results, and then design and development of peel test apparatus for further experimental study. This is regarding the 3 flexible adherent materials selected. One is the polyether ketone, second one is chitosan, third one is the polylactic acid. And their properties are Young's modulus important. We know human bone Young's modulus is around 4,000 megapascal. So peak also around 4,000 megapascal. Chitosan 1,855, PLA 2,300. Poisson's ratio, because we have to stretch it in a 90-degree direction. So it is Poisson's ratio is very important. It is 0.39, 0.3, 0.3, like that. For adhesive, there are 3 adhesive: araldite, loctite, azole, and their critical energy rate is given. Then numerical studies FEA. In that 3 phases, one is a pre-processor, in that geometry building of base, adhesive, adherent. Then material definitions, meshing, interface delamination, all these things. And then solutions and post-process. So in that we'll get this FEA model for geometry, then meshing, then interface delamination for cracks. Boundary condition, you have to apply vertical boundary condition. And from this, you will get the value of the pitch strength of the flexural adherent. Then next, there's the analytical model. In analytical model, there's a formula. From this also, we can find out the mathematical model, you can say. From this, we can find out the value of the pitch strength. So you have to compare the results. This is analytical results. When peak is used and the solution is araldite, what is the pitch strength? Similarly, when the Loctite is the adhesive, what is the strength? Similarly, you can find out for all 3 materials with 3 different adhesives, so 9 combinations. So from this, you can find out the displacement versus force. So once you get displacement, you can find out the corresponding force. And from this comparison of all biopolymers with respect to strength, so you can see peak gives the maximum value when Hyazole is a adhesive 10.88. So again, same. So you can find out here difference. And then there's a comparison between the analytical and the numerical. So this is the difference between these 2 readings, around 4%. So this is discussion. Peak is found to be best material among the 3, showing the high pitch strength and Young's modulus close to that of bone. Therefore, it is recommended to be used as a screw material in orthopedic applications, such as fixing of implemental devices. One of the limitations of the existing study highlights to carry out further research by evaluating the pitch strength experimentally. That is very important, by designing and developing a pitch strength apparatus. So the apparatus is in the stage of design. This is the apparatus. This is design of the apparatus. You can see design of the apparatus. By using this apparatus, we can find out the pitch strength experimentally. So this is the experimental result is remaining, so that we can come to the conclusion. This is the conclusion. Pitch strength is maximum when for peak 10.88. Minimum for chitosan when Loctite is used 2.52. Maximum deviation between the 2 results is 4.5%. This is references. Thank you.